Good afternoon, everyone. Now, so we were doing the interior of the earth, and in this chapter regarding the interior of the earth, we saw that this interior of the earth is divided by adverse US into three parts. What are the three parts? Sial, Sima and knife. Fine. Now there came two different sources to study the interior of the earth. Some of the sources were natural and some of the sources were artificial. Some of the sources were direct, some of them were indirect. We are not going to distinguish them. Natural sources mein, one of the study to the interior of the earth was volcanoes, and the other was seismic waves. And artificial may the temperature differences, etc. So there are three questions from here. One question will be, write a short note on the earth. Second question can be, short note on the layered structure of the interior of the earth. There are three different short notes here. Physical conditions of the earth's interior, layered structure of the earth's interior, and the role of the seismic waves in the interior of the earth. What do you mean by physical conditions of the interior of the earth? Whether the earth का some part is molten or solid, जैसे whether the earth is made up of crust, mantle or core also, या फिर, और इन सिंपल वर्ड्स मैं आपसे पूछ रहा हूं, आर दिस बोथ द क्वेश्चन सेम या थोड़ा अप्रोच अलग है? आर दे डिफरेंट और सेम? Both the questions will be slightly different. In the layered structure of the interior of the earth, you are going to write crust, mantle, core. Asthenosphere, liquid core, why it is liquid. In the physical conditions of the earth's interior, you talk about what is the physical condition of this room. Crust, mantle, core तो आएगा ही इसमें. But what will be important is also whether the pressure is increasing as we go inside the earth, whether the temperature is increasing as we go inside the earth, where the temperature is maximum, where the temperature is minimum, and what will be the density of the rocks inside the earth. That is the physical conditions inside the earth. Mostly density से related. Even if you write just temperature, density changes and just mention this is how what happens in the crust, mantle, core, you will get full marks in this. But if you write only the answer that it is crust, mantle, core, you will get minimum marks in this. Maybe you will get 2 out of 10, 3 out of 10. Getting it? So depend करता है क्या question पूछा है. Physical conditions of the interior of the earth. Obviously, you will have to mention crust, mantle and core, but you will have to mention first more write about the temperature, pressure and density differences as we go inside the earth. Getting it? What is this question? Seismic waves. So, how do the seismic waves help us to give complete understanding of the interior of the earth? Now, to study the interior of the earth, There are some of the ways of studying the interior of the earth. This is our earth, this is the mountain, and this is the ocean. Zero kilometers. Radius 6371 kilometers. उसके बाद 2900 kilometers. What is till the 2900 kilometers is the mantle. $30 kilometers. No need of drawing this diagram. Abhi. 0 to 30 kilometers is the crust. Fine. And then inside the mantle, there is a difference. 700 kilometers के ऊपर is the upper mantle. Then we have the lower mantle. Fine. Similarly, 5100 kilometers, we have outer core, and after that we have inner core. In the asthenosphere, in the upper mantle, the upper part of the mantle up till the depth of 200 kilometers is asthenosphere. How do we know this is so properly? कि इसके depth पे this is there, in this depth this is there. This is because of some of the observations. Now there are two ways of studying: natural, artificial, direct, indirect. One of the direct way of studying the interior of the earth is you dig a hole inside the earth, go deep inside the earth and see what are the physical conditions that are present inside the earth. Possible hai? No. You can go only up to the depth of 4 kilometers. Fine? So usse you will not know the entire interior of the earth. Second, to study indirectly the temperature pressure differences. Yes, how the temperature is going to increase, how the temperature is going to change, but ये सब होगा by some kind of an assumptions कि ऐसे होता होगा. You cannot still know properly the interior of the earth. Third is to study what comes from the earth. What is coming out from the earth is volcanoes. Now when you study volcanoes, you will understand if this is the volcanic eruption that is occurring in one specific region, maybe this region is rich in iron ore, or maybe this region is rich in copper अगर नीचे से आता है. But problem is maximum depth of volcanic eruption is 200 kilometers, that is asthenosphere. You will not have an idea of the earth below the asthenosphere. Then the fourth way of studying the interior of the earth is through indirect observation. You will have to study the waves that are generated during the earthquake, and these are waves which are known as seismic waves. Then you calculate if this is the speed of a wave in an earthquake, during an earthquake, it should come after maybe 7 minutes. If it does not come after 7 minutes, means it has gone through a medium जहाँ पे उसकी speed has decreased. Why the speed has decreased? Because maybe it is less dense. Which is less dense? Always liquid. Or this. If the speed suddenly increases, it is extremely dense. Getting it? So this assumptions, by doing this assumption, we have a complete idea regarding the interior of the earth. So that is why role of the seismic waves in studying the interior of the earth. This question can be changed in another manner. What is the importance of the seismic waves in studying the interior of the earth, or why they are the best source to study the interior of the earth? Fine. Why they are best source? Because the other sources are not good and this is only good. So if the question is examine the significance of seismic waves in studying the interior of the earth, or explain why they are the best sources to study the interior of the earth, जब ऐसा question आता है तो हमेशा think why they are best source, means examiner wants to know why the other sources are not good. So you will have to give one paragraph to what I have said. 4 kilometers से ज़्यादा you cannot go. Getting it? Or you cannot go study more than 200 kilometers below the interior of the earth. Getting it? You will have to study these things. And if the question is direct, role of the seismic waves, like this what I have given, directly shuru karo. The interior of the earth can be studied with the help of waves that are generated during the earthquake, and these are the waves. How many of you have idea of how the seismic waves behave in the interior of the earth? You have an idea how the P wave will behave, how it will change the direction, how it will not change the direction. First, we will study about the physical conditions of the interior of the earth. How? In the physical conditions, सबसे पहले temperature. क्या पता है टेम्परेचर के बारे में? As we go down, the temperature will increase or decrease? Increase. At what rate? वो तो ऊपर जाएगा तब टेम्परेचर डिक्रीज होगा 6.5 डिग्री सेल्सियस। कल मैंने बताया था आपको 1 डिग्री सेल्सियस फॉर एवरी 32 meters temperature is going to increase. Means what will be the temperature at 1000 meters or 1 kilometers or 3200 meters? Chalo, it is easy for you. What will be the temperature at 3200 meters? 100 degrees Celsius. What will be the temperature at 6000 meters? 200 degrees Celsius. So क्या अर्थ के इंटीरियर में द टेम्परेचर इज ओनली 200 डिग्री सेल्सियस? नो, अर्थ के इंटीरियर में एज यू गो टू द एस्थेनोस्फीयर द टेम्परेचर विल बी 6000 डिग्री सेल्सियस. दैट मीन्स द टेम्परेचर इंक्रीजेस at rate that is higher than the 1 degree. Fine. Then why we make such generalization? The answer is, why is this semi-solid in nature? When three states of matter. If you heat the solid, it will get converted into liquid. If you heat the liquid, it will get converted into gas. So can I say this is semi-solid in nature because temperature is high? Right? So as we go down, the temperature goes on increasing. Then after that, as we go down, again this is solid in nature. Can you tell me why? Or temperature decreases. When does liquid become solid? When you cool it. When does the gas becomes solid, liquid? When you cool it. So as we go down, is the pressure increasing? Yes. What is the pressure? The weight of anything above your head. Right now, हमारे ऊपर किसका pressure है? There is a pressure of atmosphere. But if you go below the earth, there will be the pressure of rocks. If you go into the swimming pool or river or well, there is a pressure of water. Fine. So imagine if what is the any general idea what is the pressure of atmosphere on our body right now? It is 1035 millibars per centimeter square. कोई याद रखने की जरूरत नहीं. Or it is 1 kg per centimeter square, equivalent to. So each centimeter of your body, square centimeter of your body has atmosphere का pressure which is equivalent to 1 kg. जितनी बिग बॉडी उतना ज़्यादा एटमॉस्फेयर का प्रेशर, जितनी कम बॉडी उतना कम एटमॉस्फेयर का प्रेशर. अंडरस्टैंडिंग? देन व्हाई आवर बॉडी डज नॉट फील द प्रेशर? बिकॉज योर हार्ट इज पंपिंग and heart is giving out the same pressure so that it is matching the pressure of the atmosphere and your body is stable. But if the pressure of the atmosphere increases and your heart does not give that much pressure, heart attacks. Getting it? Low blood pressure, high blood pressure, what is this? You have to match the atmosphere ka pressure. So if your heart does not give that much pressure, what will happen? Your body will crumble, your heart will burst, brain hemorrhage. Or if your heart also gives extra pressure ki atmosphere se zyada, again brain hemorrhage. Brain hemorrhage, blood vessels will burst. So when you go down into that earth, what is going to increase? Pressure. When you go up into the atmosphere, what is going to decrease? Atmosphere ka pressure. So sometimes when you go on a lift, very suddenly थोड़ी चक्कर आती है for some seconds, and once you come out you feel good. क्यों? Pressure decreases. Or when you go up on a mountain, you carry oxygen mask because pressure is less. Fine. Now the difference is when you go below the surface of the earth, it is no longer atmosphere ka pressure, it is the pressure of rocks, and the pressure of rocks is million times greater than the pressure of atmosphere. Obviously because of this you cannot go below 4 kilometers. Technology kitni hai? If you take something by the help of technology where nanoparticles which can withstand 6000 degrees Celsius, you can go till the interior, but it is not possible. Why? Because pressure is very high. Understanding? We don't have technology to match the pressure that atmosphere puts. Now if you go deep, is the temperature increasing? Yes. Is the pressure increasing? Yes. If you go very deep, pressure increases to such an extent that increase in the pressure reduces or increases the melting point. So if any material which melts at 100 degrees Celsius, fine, if you increase the pressure, uska melting point may increase and uska melting point may become 150, 200, anything degree Celsius. So because as you go down the pressure increases, upper mantle, lower mantle is solid. The increase of the pressure cannot match the increase of the temperature. And further as you go down, the pressure does not increase to such an extent as temperature, and therefore the outer core, यहाँ पे temperature is dominating, is liquid in nature. The reason is because the outer core is mostly made up of nickel and Nife. Core is Nife layer, iron and nickel. Now which is more denser out of nickel and iron? Iron is more denser, and denser material will settle. Fine. So iron has settled and formed, become an part of inner core. Pressure is, वैसे ही iron का melting point is very high. Iron and steel industry में the iron का melting point is 4000 degrees Celsius. Iron ka melting point is anyways high, and plus pressure is so high that iron does not melt and the inner core is solid in nature. But the outer core is mostly made up of nickel, and nickel can easily melt at 2000 degrees Celsius. Therefore outer core is liquid in nature. Getting it? Why? There are variations. So the three physical conditions, temperature increases. Does it increase in a orderly manner? No. There is a change in the increase of the temperature, but we don't know change. But by looking at this diagram, by studying the seismic waves, we have understood that temperature initially increases at a very high rate, and therefore this is in the molten state, and thereafter that the temperature increase, rate of increase of the temperature decreases. Understanding everyone? Pehle the temperature will increase at very great rate, therefore this is in a molten state, asthenosphere, जहाँ से volcano comes out. After that the rate of increase of the temperature decreases. How do we know rate of increase of the temperature decreases? Assumptions. What assumption? Had the temperature increased at the same rate, the earth pura would have been liquid. Had the earth pura would have been liquid, life would not have been possible. क्यों? Because earth is a sphere, उसके अंदर liquid and it is rotating. When you rotate a sphere with liquid, it will bulge at the center, it will burst. Or when you rotate the sphere with a liquid, there will be wobbling on the axis. तो earth rotate properly करता है, ऐसे नहीं ऊपर नीचे जाता है. Getting it? Fine. So we then conclude that maybe pressure is so high कि earth का these things are not at the melting point. And the third physical condition is density. There is no question about density. Density नीचे जाओगे तो increase होगा. Now can someone tell me what do you mean by density? What is the difference between density and pressure? ये बहुत problem होता है even in GS students को. In simple words, mass by volume is density, but in simple words, what is density? Yes, that is, if this is a box or if this is something, how much the molecules or the particles are closer. If they are extremely close, they are denser. If they are having space, they are less denser or rare. So if the particles are closer, means if the material is more denser, can a sound wave pass with great speed or not? Well, see, 3 examples. You only tell me. I am sending a sound wave through wood, through liquid and through air, where the travel of the sound wave will be maximum. Speed. Wood, air, water. साउंड वेव का स्पीड सबसे ज़्यादा इन साउंड वेव ट्रैवल्स विथ हाईएस्ट स्पीड इन द मटेरियल विथ मैक्सिमम डेंसिटी एंड देयरफॉर द साउंड वेव का स्पीड विल बी ऑलवेज ग्रेटर इन वुड. अब वुड से ज़्यादा डेंसर क्या है? आयरन. साउंड वेव का स्पीड एक्चुअली शुड बी डेंसर इन आयरन, बट आयरन इज सो कॉस्टली दैट इंस्टेड ऑफ आयरन, and iron is not easily malleable and ductile, so instead of iron we use copper for transferring the sound wave. Getting it? अगर sound wave would have been so good in the air, मुझे mic की ज़रूरत ही नहीं पड़ती. I would have said and you would have listened. Fine, but I have to use amplifier. Amplifier say that sound wave goes into the machine, then it is sent to the speakers. Then the speaker is giving the output at an instant. This shows the speed of the sound wave through the materials with density. So which is the most densest material? Core. The speed of a sound wave should be highest in the core, and sound wave ke jaisa hi we have a wave which is known as P wave, and the speed is highest. Getting it? So as we go down, density goes on increasing, except density is lesser in liquid outer core. Getting it? So point number 1 regarding the physical conditions of the interior of the earth. See, clear the concepts even if you are not doing GS, because ये सब लगेगा हमें even in you will require this or even in GS. Atmosphere is less denser, atmosphere is more rarer. You see the past year questions, they have given you this option. Arrange them in the descending order as per the speed of sound wave. Descending order. So highest speed, the one which is densest. The density, hardness. Generally hardness will be, so iron. उसके बाद wax or wood. Wood. उसके बाद wax. उसके बाद water. Fine. कम करना है, ज़्यादा करना है? So this thing we can take down physical conditions regarding the interior of the earth. To study the interior of the earth, give me the remote. Study the interior of the earth. There are some artificial sources. As well as some natural sources. The artificial sources are tell me, volcano artificial, natural? Natural. Mining, artificial. Digging a hole or mining industry? Digging a hole, artificial sources are 1. Digging a hole or mining industry. Second, studying density, pressure and temperature differences. Studying density, temperature and pressure differences. And third, Deep ocean drilling projects. Deep ocean drilling projects. I'll only explain you what is deep ocean drilling. I won't touch the parts of GS. ये सब GS का part है. Mining, deep ocean drilling, etc. Optional has, these topics are too easy for optional. They will never ask you these topics. Getting it? Natural sources are volcanicity, seismology, and the study of meteors which fall on the earth. Study of meteors which fall on the earth. Which fall on the earth. Which fall on the earth. तो सबसे पहले physical conditions regarding the interior of the earth. उसके बाद interior of the earth. Pressure and density. Temperature. Understand only in points. कोई रटने की ज़रूरत नहीं है. You just understand. What will be the first line? As we go down, the temperature goes on increasing. Therefore, the temperature goes on increasing. Most of the earth should be liquid in nature. But that is not the case. Only some part of the interior of the earth are liquid, some part are solid. That means temperature does not increase at a same rate. फिर उसके बाद बताना एग्जामिनर को how does the rate of temperature increases. उसमें what you will say, which part is liquid in nature, uppermost part या lowermost part. सबसे पहले which is liquid in nature or molten asthenosphere. Then you have to tell to the examiner that because of the rate of temperature is very high in the upper part and therefore asthenosphere is liquid in nature. कुछ facts याद नहीं रखने. उसमें लिखना है why it is very high, because it has dominance of atomic or fissile material, and because it is a fissile material such as uranium, it melts easily and therefore asthenosphere should be liquid in nature, but it is not liquid in nature, it is jelly. Jelly and liquid में फर्क. You know the difference between jelly and liquid, right? So why it is jelly in nature? Pressure. Due to increase in the pressure, melting point also increases. Khatam. Come directly to pressure. It is very obvious that pressure will go on increasing. Vary nahi karega rate because pressure depends upon rocks. As you go deep, the pressure of the rocks, weight of the rocks will increase, and therefore pressure increases. Obviously, density increases. Density may already know what you have to write. Continental crust, less density. Mantle density increases. And which is the highest density? Core. Why it is having the highest density? Because of the presence of iron. Fine? हाँ. कौन सा? नहीं. Assumptions वो सब नहीं mention करना. क्यों assumption mention नहीं करना है? क्योंकि देखो volcanic eruption से what comes out, liquid or solid? It is not actually liquid, neither solid, it is that jelly like molten rock. You are 100% sure it is now molten state. Studies have shown the maximum depth of volcano is 200 kilometers to 400 kilometers. So the zone where the rocks are very weak, that is they are in the molten state. They are not in the solid state, they are in the molten state, that is why they are weak, is known as asthenosphere, because astheno means weak, sphere means area, that is why the name is asthenosphere. So it is no longer an assumption. Fine. Then does earth have a magnetic field? Yes. Which body can have a magnetic, as earth, does it behave like a magnet? Yes or no? Yes. Do you use that magnetic field in your everyday life? How? In your simple this thing, open Google Maps. It is showing you navigation on the basis of satellite. Usme, if you change the orientation north south, the maps will change. That is pointing to the north and south. Uske thode right hand side ke corner mein dekhna, there is north and south given. That is, it points to the north. If you change the direction of the compass changes. So Earth has a magnetic field and it is pointing to the north and south. Which body can have a magnetic field? How does the Earth has a magnetic field? Remember, because of presence of iron. So tomorrow I am wearing a watch having an iron. Will I behave like a magnet? No. No, it is not possible. और यहाँ पे भी थोड़ा बहुत आयरन है ही. Earth has a magnetic field because Earth के अंदर there should be some minerals which are in the molten state. Fine? And Earth is spinning, rotating at a very high speed. When the minerals which are in the molten state spin at a very high speed, what happens? There is a electric charge is created. Why? Because any minerals have some ions which are positive ions, some ions which are negative ions. Forget about minerals. Take your comb today and rub it on your head with a very high speed. उसमें भी electricity आएगा. Fine? So these are the minerals, and these minerals will rotate at a very high speed. And as a result, inside the earth, positive and negative charges are created. So where is the liquid to rotate? Outer core. It rotates with a very high speed, creating positive and negative charge, and therefore earth में से charges are given out. When the earth में से charges are given out, these charges of the earth, I will go to this. If this is the interior of the earth, this is how the charges are given out by the earth. Now, even in your 8th standard and 9th standard, you must have studied Fleming's left hand rule. That is, if this is the direction of electric charge, the direction of thumb is the direction of magnetic field. And hence, earth ka magnetic field is this way, north and south magnetic field. So we have north pole and we have south pole. Fine. Earth behaves like a magnet not because it has iron, but because it has liquid outer core. And because of the liquid outer core, this is not liquid, this is properly liquid. Due to the liquid outer core, there is creation of electric charge, and electric charge, as a result of this, we have a magnetic field. And because of this magnetic field, understand, sun rays, I have told you in GS, solar winds, sun rays come in the form of electromagnetic spectrum. They are having very high charges. They collide with the earth ka magnetic field. Because of collision, this electric charge is sent to the regions jahan pe the magnetic field is very strong, that is at the poles. And here it reacts with the earth's magnetic field. Here it reacts with the earth's magnetic field. And due to this, there is spark in the sky, and you must have studied an aurora australis. Getting it? We'll see a video at the end of the lecture how the magnetosphere of the earth is. So that is how, and what she said, earth has a magnetic field due to presence of iron. She is not wrong, because Suez ko bhi yahi laga tha. Suez ka one concept is earth behaves like a magnet because it has iron. These things have changed. Earth has a magnetic field due to these things have changed after the use of computers, because unless there are computers, unless there is a computer modeling, you will not know specifically. Fine? So, temperature. There is a general rule that the temperature will keep on increasing. Temperature will keep on increasing as we go inside the earth at the rate of 1 degree Celsius for every 32 meters. At the rate of 1 degree Celsius for every 32 meters. Thus, the increase in the temperature, is also proved by presence of hot springs. Have you ever gone to hot spring? Have you seen the hot spring? What is hot spring? नीचे से पानी आता है. Geysers and hot springs. And how is the water? Very hot. Fine. Why is this so? Because the water is touching the magma. Presence of hot springs. You know what is hot spring? So, have you seen an area जहाँ से water is coming up and it is extremely hot? That is a hot spring. So, geyser, yes. बहुत ज़्यादा. Volcanoes. It is proved by the presence of hot springs and volcanic activity. It is said that temperature inside the earth is around 4,000 to 6,000 degrees Celsius. But if we take a general law, that temperature increases at the rate of 1 degree Celsius for every 32 meters. Temperature increases at the rate of 1 degree Celsius for every 32 meters. Then the temperature in the core should be around 2 lakh degree Celsius. Understand the statement again. The temperature should be 2 lakh degree Celsius. कितना है temperature inside the earth? 4,000 to 6,000 degrees Celsius. What does the law say? 1 degree Celsius for every 32 meters. So for 3 kilometer the temperature will be 100 degrees Celsius. The radius of the earth is 6,300 kilometers. So if you apply this, temperature will be so high that it will be 2 lakh degrees Celsius in the core. Will be. But is it? No. Why? Because at such high temperature, the earth would have got destroyed. Even if it would not have got destroyed, the earth would be very hot from below. Earth would have been gaseous. या earth के अंदर उबलता हुआ liquid रहता. There would have been boiling water on the earth or boiling liquid on the earth, making life impossible. So means you are staying on the earth और नीचे 2 lakh degree Celsius है. Can you stay? नीचे से हमेशा गर्म, except for volcanic eruption, नहीं तो हमेशा गर्म रहता, जलती skin. But this is not the case. So next point. This is because numerous studies have shown that temperature increases at a very fast rate. Only till top 100 kilometers. Till top 100 kilometers. 100 kilometer tak. And after that, the rate of increase of the temperature decreases. the rate of increase of the temperature decreases. It is estimated that the temperature in the crust is around, temperature below the crust, not in the crust, sorry, temperature below the crust is around 3000 degrees Celsius, and the temperature in lower mantle and the core is around 4000 degrees Celsius. Around 4000 degrees Celsius. In mantle and core is around 4000 degrees Celsius. Next point. So, कहाँ पे temperature is maximum? In the asthenosphere. So, that is why you know asthenosphere is semi-solid. That is the next point. Therefore, the zone below the Earth's crust, up to 200 kilometers, is the zone of weak rocks known as asthenosphere. And it becomes the source of what? It is magma or lava that is given out through volcanic eruptions. Is the source of magma, or known as asthenosphere, is the source of magma or lava which is given out during volcanic eruptions. GS के लिए याद रखना, astheno means weak and sphere means zone or area. So, asthenosphere is the zone of weak rocks. Asthenosphere is the zone of weak rocks. See why you should, no need of going into detail, but हमेशा generate the answers in the exam. There are some areas geomorphology ज़्यादा पढ़ने की कोशिश मत करो, समझो and generate the answers in the exam. सिर्फ दिमाग में याद रखो diagrams. So as you go down, volcano है, that means temperature is increasing. So you should just know in the keyword at what rate the temperature is increasing, 1 degree Celsius for every 32 meters. But if you go down at that rate, temperature will be very, very high, which is life will not be possible. That means the temperature initially increases till 100 kilometers at a very high rate, and then the temperature becomes stabilized. So here the temperature is around 3000 degrees Celsius. Just below 100 kilometers, but after that you see from 100 to 6000 kilometers temperature is only 4000 degrees Celsius. That is only 1000 degrees Celsius has increased. So, asthenosphere. Fine. Then pressure or density. First take pressure. As we go below the earth, the pressure goes on increasing. Due to the weight of overlying rocks. Due to the weight of overlying rocks. ऊपर वाले rocks. Overlying rocks. Weight of an overlying rocks. the pressure of the rocks, the pressure of the rocks is around is around प्रेशर हम हमेशा एटमॉस्फेयर के हिसाब से वी मेजर. सो एटमॉस्फेरिक प्रेशर 1 kg per square centimeter. So pressure of the rocks will be 1 million atmosphere, means 1 million kgs per square centimeter. The pressure of the rocks will be 1 million atmosphere at the depth of 1500 kilometers. At the depth of 1500 kilometers. And since the pressure increases to such an extent, since the pressure increases to such an extent, there is increase in the melting point of the rocks. There is increase in the melting point of the rocks, and hence majority of the earth's interior is solid in nature. Majority of the earth's interior is solid in nature. Majority of earth's interior is solid in nature. Draw the diagram with me. Will this graph be exponential? Yeah, rising very constantly. Means, will this graph be stagnant? Yeah, increase. Means at the depth of 0 kilometers there is very less pressure. But at 1000 kilometers the pressure increases. 2000 kilometers my pressure will again increase. Where does the core starts? At 5000 kilometers, and thus pressure will be maximum at the core. Getting it? This? What is this? A graph of pressure and depth. Kilobars, not millibars. Millibars, then we will have to make very long diagram. and depth in kilometers. Done? Can I continue? See, there has been no question on the interior of the earth ever asked by UPSC except seismic waves पे. Bring out the relevance of seismic studies in determining the structure of interior of the earth. That is, UPSC को भी पता है, even this is studied in GS. Why they will ask such easy topics in optional? Fine. Whose book is with me? Next, density. Density. We can infer, we can conclude, or we can infer that as pressure goes on increasing, the density should also go on increasing. Density also goes on increasing. Pressure goes on increasing, the density will also go on increasing. Fine. I am taking this book, I am putting the pressure on this book. Will its density increase? If I put more and more pressure, will its density go on increasing? Yeah, at a critical point, book will be destroyed. The book will be destroyed. At a critical point, the book may be destroyed. Means, can I say the rocks will have a critical limit beyond which uska density cannot be increased? Had all the material made so denser, तो फिर superconductivity would have been our solution. But we'll have to look only at certain materials for superconductivity. Conductivity, the speed at which the electricity can travel. There are some of the conductors, some of the resistors. ये सब geography का नहीं है. I am just telling you what is superconductivity. This electricity, light, etc. travels with such a great speed that it makes possible the extraordinary things. That is, you will send an electricity current from Delhi and New York instantly, lights लगेगा. So that is what is the superconductivity. कहाँ use होता है? Fiber optics. ये कैसे आ रहा है? 100 Mbps की इंटरनेट की स्पीड. When just 5 years back, 1 Mbps was considered to be a very good speed. Abhi directly 100 Mbps. Or if you remember the school days, 100 or 10 kbps was very good speed. Fine. So this all is occurring due to the superconductivity, but superconductivity is not possible in each and every mineral. So there is always a critical limit beyond which the if you increase the pressure, density increases. But we have studied, we have inferred that density is very, very high as we go down. Which means, is it only due to pressure? No. The density of the earth also increases because as we go deeper, the materials are more and more denser. Lighter materials such as silica and aluminum, usse zyada materials such as magnesium, usse zyada materials such as iron. Getting it? This is what I wanted to tell you. So point number 1 we had written, pressure increases, therefore density increases. Second point, the earth is denser. The earth is denser because as we go deeper inside the earth, the density of the materials increases. Density of the materials increases. Example. The core, due to presence of extremely dense iron and nickel, has highest densities, while the crust is made up of light rocks, while the crust is made up of lightest of all the rocks. आइस्टोस्टेसी का कल मैंने एग्जांपल दिया था, दैट इज माउंट एवरेस्ट का रॉक्स विल बी लाइटर और डेंसर. लाइटर, हायर द माउंटेन द रॉक्स विल बी लेस denser. Getting it? That is why uska height is greater. See, all these are examples which have been done by geographers. They have taken in the water, but water mein nahi, mercury mein 3 cubes, 1 cube of wood, 1 cube of iron, 1 cube of nickel. Wood ko dala, iron ko dala, nickel ko dala. Iron went सबसे down, nickel at the top and wood again at the top. And they said mercury means we human beings, wood matlab Mount Everest, therefore lightest and highest has highest height, and iron means any kind of an plateau, peninsular plateau region. Getting it? So what you should remember only for the exam, that is core densest, not just because of pressure but also because of the presence of heavy metals. क्यों? अंडे को याद रखो, boiled egg को याद रखो हमेशा. Whenever you get stuck in the examination, remember boiled egg. The yellow color of the egg is heavy, dense. That is why it has settled at the bottom. उसके बाद mantle, egg white. उसके बाद crust, lightest. The same thing is happening in the egg. One last point. This can also be proved. क्या by boiled egg? No. वो exam में नहीं लिखना होता है. This can also be proved by the study of meteors whose core is exposed when they reach, whose core is exposed when they reach the Earth's surface. And this core is made up of nickel and iron. This core is made up of nickel and iron. Now, what do you mean by meteors? Extraterrestrial object, dust particles which is going around in the space, which sometimes fall inside the earth. So these meteors, when they come inside the earth, majority of the meteors are destroyed in the mesosphere, by the atmosphere. But some of the meteors, when they come with great high speed, there is a friction, they burn. And because of burning, their crust is destroyed, their mantle is destroyed, and if they reach the earth, their core comes. Getting it? Outer layer is destroyed, inner layer is destroyed, only core is left. By studying the core of the meteor, we can understand the core of the earth. Kyun? Because everything is formed by the same process, Big Bang theory. Everything is formed by the same parent matter. Agar meteors ka core is divided into 3 layers, that means Earth is also divided into the 3 layers. That means Jupiter is also divided into the 3 layers. That means Mars is also divided in the 3 layers. Getting it? Universal. This is a universal truth. The only thing is, some of the planets are lighter, some of the planets are rockier, some of the planets are gaseous. उसमें भी even in the Jupiter, the outermost gases will be light. अंदर जाओगे heavy, अंदर जाओगे और heavy gases. Getting it? So if core is coming with great speed, if meteor is coming with great speed, उसका crust is destroyed, mantle is destroyed, but core is exposed. Scientists then study the core, and if the core is nickel and iron, and all the cores of the meteors have been nickel and iron. Any meteor which has fallen recently on the surface of the earth? No. If meteor falls on the surface of the earth, we will die. Then how do we know कि उनका core is made up of iron? There are some of the meteor lake. For example, one lake is in India, which is known as Lonar Lake. It was formed due to the impact of meteor. 3.2 kilometer का meteor came and hit the earth, causing a depression. And उस लोनार लेक में नीचे से फिर ground water came up and it is now become a lake. Even today, that lake does not have a single life. Why? Water is nothing but iron and nickel. Why? Because it is made up of destroyed core of the meteor. Getting it? So ये GS के लिए एग्जाम्पल याद रखना. It has been asked in the optional also. क्यों? Optional में पूछा है. Lonar Lake. You have map pointing in paper 2 for 40 marks. तो वो देते हैं ऐसे meteor Lonar Lake. You have to write 30 words about it and you have to show it in the map, locate it in the map. Words के लिए there are 2 marks, locating in the map के लिए there are 1 mark. So even if you don't know उसका position exactly, हमेशा याद रखना what to write. So 30 words किस में खत्म हो जाएंगे? It is located in the state of Maharashtra. 5 words. It is formed due to the presence of hitting of the meteor. Salinity is very very high. खत्म 30 words. You are going to get at least 20 में से 15 marks. 5 mark ही miss हो जाएंगे. 1 mark even if you don't locate. कभी कभी time नहीं होता. When you write the mains, you will see कि time नहीं होता. So the best is just to write. So if there are 20 marks for that question, fine, and 1 mark is given for map pointing. Don't score this 1 mark, but score at least remaining 15 marks. Getting it? Many times places come from the current affairs. Have everything is there in this booklet. So 2018, I'm showing you what the map pointing ka question is. Section A, 20 marks. और ये चेंज होता है. कभी 2 marks के लिए पूछते हैं, कभी 5 marks के लिए पूछते हैं, कभी 60 marks के लिए पूछते हैं. If it comes for 60 marks, you should be the most happy person. Because in no other optional, if you are a good student, 60 marks are in the hand. If you write everything, examiner has to give you 55 marks at least. That is why when this question used to be for 60 marks, toppers were generally from geography or history. अब ये 20 marks कर दिया because this they used to get advantage. So I pray to God कि इसको फिर से just like पहले जैसा 30 marks तो कर दे at least, because ये हाथ के marks है. So Shok River, very general, everyone you will once you study GS you will understand where is the Shok River. Shok is a tributary of Indus. It flows through the glaciated region. Malonong, क्यों पूछा? Uranium deposits, current affairs. Sravasti. What is Sravasti? कहाँ पे? क्या? Why it is significant? For? Yes, Gautam Buddha से related. Means questions can come even from your history knowledge. Kori Creek, Gujarat. Sir Creek issue was in the news. Amarkantak, very easy. Ghatashila. History again. Tawang, Arunachal Pradesh monastery. Nayyar, Southern India, famous for iron and steel deposit. Dandeli, a national park. Mulshi Lake, near Pune. So you can see 2 comes from ancient, one or two comes from current और बाकी के तो are very easy. Dandeli is very easy. Then Mulshi Lake is easy. Mulshi Lake क्यों आया in 2018? Can someone tell me who is following the current affairs? Why this is there? Because of riots between Dalits and Brahmins on Sambhaji issue. Bhima Koregaon issue, what is known as, it was at the Mulshi Lake. That is why it has been asked. Getting it? So, current based questions आते हैं. Fine. And now, study of the seismic waves through we'll first do through the natural sources. What are the three natural sources? Volcanicity. Second, meteors. And third, seismic waves. Can you write about first two, volcanicity? Why it is a good source? Because you know what comes from inside the earth. Why it is a bad source? Because you cannot know anything beyond 200 kilometers. Meteors, why it is good source? Because it reveals how the universe was formed and how the meteors and the earth is made. Why it is a bad source? Because meteors are not always welcome. Because कि हमें study करना है इसलिए meteors keep on falling. That is not an issue. That is not a good thing. So natural sources, volcanicity. When lava or magma comes from below the earth, it gives an idea of the materials that are present inside the earth. It gives an idea of the materials that are present inside the earth. Gives an idea of the materials that are present inside the earth. But most of the volcano originate between 40 to 50 kilometers, at the depth of 40 to 50 kilometers, originate at the depth of 40 to 50 kilometers, and seldom originate or do not originate, whatever you have to write, and seldom originate or do not originate below 200 kilometers. Below 200 kilometers. And therefore, study of volcano do not give a complete understanding of the interior of the earth. Study of volcano do not give a complete understanding of the interior of the earth. Meteors, you already know क्या लिखना है इसमें. The study of meteors will give us an idea of core, that is, but meteors do not reach the earth or only their core is exposed. But what if you want to study the mantle and crust? It is burnt. Fine, so don't take down the meteors. When the meteors reach the earth, their outer layer is burnt, exposing the core, and thus we can have an indirect idea. Thus we can have an indirect idea. We can have an indirect idea of how the core was formed and the constituents of the core, matlab the materials in the core, and the constituents of the core. But again, the study of meteors, do not give a complete understanding. Do not give a complete understanding. So which gives the complete understanding? Seismic waves. Many people here do not know, understand. ये थोड़ा complex है. This topic is bit complex. So try to understand. What are the seismic waves? We will write it separately. The waves during earthquake. Where does the earthquake originate? Earthquake always originates inside the earth or on the surface of the earth. The earthquake always originates somewhere inside the earth. The point where the earthquake originates is known as focus or hypocenter. Hypocenter or focus is always deep inside the earth. And the point which is nearest to the hypocenter or focus on the surface of the earth is what is known as epicenter. Now inside whenever the earthquake originates, there are two kinds of the waves. One which flow from inside the earth, and you will call these waves as body waves, not P waves. And one which flow on the surface of the earth, and you will call these waves as surface waves. What topic are we studying? Interior of the earth. So what we are going to study? Body waves. Fine, we are not concerned about surface waves. So body waves are of two types. One is similar to sound wave, and you will call this as P wave. One is similar to ripple marks on the water, and you will call this as S wave. Why this P wave? Because it is the first wave to be generated and to be recorded. कौन record करेगा? When the earthquake is originating here, there are seismographs located at many places in the world. Each and every district has a seismograph in India. Maybe seismograph is present even at the taluka place. Remember, government जहाँ geological survey का office is there or sub center is there or geological survey का anything is in the collectorate, you have seismographs. Fine. So seismographs are present, and this wave after generating, when it is recorded on the seismograph, the first wave to be recorded is P wave, and therefore उसका name is primary. The second wave to be recorded is S wave, and therefore इसका name is secondary wave. Now what is the characteristics of a primary wave? The characteristics of a primary wave is it is similar to the sound wave. What is the characteristics of the sound wave? That means it can pass through. Does the sound wave pass through solid? It can pass through solid. Can it pass through liquid? Sound wave? Yes. But does it pass? Can you speak in water? Yes. Can it pass through air? Are you hearing my sound? So it can pass through solid, liquid and gas. But speed will depend upon density. So it will pass with maximum speed in the solid, uske baad in the liquid and uske baad in the gas. Now interior of the earth cannot be gaseous. It is not that we are living on a balloon. Fine. Second is it is longitudinal wave. अब ये सब ऑप्शनल में नहीं लिखते अनलेस दे हैव स्पेसिफिकली आस्क्ड. ऑप्शनल में क्वेश्चन विल कम, हाउ seismic waves will help in studying the earth's crust. You will have to just stop here, or if you want to mention here, you can mention what you mean by longitudinal wave. So if this is the movement of wave direction, right, this is how the wave is moving. Have you seen woofer in a car or in the house? Woofer या any speaker, does it go up down or does it go this way? So the sound is being put and woofer also is vibrating in this direction. Why is this? Because the sound wave similar to P wave, P wave similar to sound wave. In any wave you have to understand, if this is the direction of wave movement, the particles vibrate in this way, this way, this way and this way. Getting it? This is that is अगर P wave ऐसे जा रही है, this is an P wave which is going, the vibration of the parallel particle, so this is the direction of the P wave. इसके अंदर if any particle, now what that particle can be, you, that particle can be building, that particle can be stone, that particle can be anything, the particle will vibrate to and fro. ऐसे घूमेगा पार्टिकल, ऐसे 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 ऐसे, दैट इज इट इज गोइंग टू वाइब्रेट दिस वे. सो इज द पार्टिकल वाइब्रेटिंग पैरेलल टू द डायरेक्शन ऑफ द वेव और इज वाइब्रेटिंग परपेंडिकुलर टू द डायरेक्शन ऑफ द वेव? इट इज पैरेलल, देयरफॉर वी विल कॉल दिस एज longitudinal waves. So when anything is vibrating parallel to the direction of the wave, क्या होगा? Understand it with this book. It is getting, this is a house, this is a house, it gets caught in the P wave. P wave is called parallel vibration. So due to parallel vibration, sometimes the house will be compressed, sometimes expanded, compressed, expanded. Getting it? So P wave mein there is a compression of the rocks, expansion of the rocks, compression of the rocks, expansion of the rocks. Any one of you have experienced earthquake or tremors? What happens? सबसे पहले a weak tremor comes. उसमें fan ऐसे ऐसे होता है या ऐसे ऐसे होता है? That is P wave. S wave experience हुई थी, कैसे पता चला X wave थी, S wave थी? That is what is the, but S wave is dangerous. So the जो सबसे पहले tremor है, whichever comes during the earthquake, it is the primary wave and it is the least dangerous. That is why they ask you कि run out of the house. अब ऐसे में वाइब्रेट कर रहा है घर, फिर ऊपर नीचे वाइब्रेट करेगा और घर गिर जाएगा. Fine. Now what is the secondary wave? The next wave to be generated, it is known as the secondary wave. And what is उसका characteristics? It passes only through solids. Why it can pass only through solid? Because it requires shear strength. Shear strength is a concept in physics. Any body which can hold uska shape, then through that body only the wave can pass. Example, electricity. Can it pass through air? Can it pass through air कि यहाँ पे live wire है and I am getting a shock, you all are getting a shock? No, क्योंकि air does not have any strength. But if you hold it, can it pass? If you hold me, can it pass to you? Yes. That is what is the shear strength. A wave जिसको body strong चाहिए. So which is strong? Solid. So S wave can pass only through solids. And if this is the direction of an S wave, how will be the vibration of the rocks? Up, down, perpendicular, and therefore we will call such wave as transverse waves. And it will also pass with more density, more speed. इसके लिए also law is more density, more speed. Fine? Understood everything here? Any doubts? Can I continue? Can I rub all these things? ये हम फिर से लिखेंगे first. The way I explain you and make points like this is what you should be doing while revising the subject and make micro notes. Because our booklets will be thick, so you should have notes ready so that you can revise them soon before the examination or after the prelims. This is the earth. Earth is divided into crust. Mantle. And the innermost part is core. Crust, mantle and core. Blue color I will show with P wave. A P wave starts and as it goes down, see what is happening. Uska speed is less. Fine? Then it comes here, uska speed is less. And after 200 kilometers, there is sudden increase in the speed. And as it goes down, their speed goes on increasing. And then it goes in this manner. Again, uska speed decreases because it is coming nearer to the crust. And further, there is a decrease and decrease in the speed, and then it is recorded here. Secondly, it is going this way, speed decreases, then increases, then decreases, and it is recorded here. So the first question is, why it is not traveling in a straight line? Why it is bending? Because the law is refraction. Waves bend or refract whenever they pass through the medium of different densities. So by the direction of the waves, because they are not, ऐसे कभी नहीं होता कि this is a focus and wave is recorded here. That means, what is the first conclusion we can draw? That is, the earth is made up of materials of different densities, which has already been proved by C.L. Sima, but they are proving it now. Secondly, a P wave comes. So this is how the P wave is generated. A P wave comes. It comes here. Speed is high. And suddenly there is maximum refraction. But the speed becomes less. And then after some time the speed is high. Again there is maximum refraction. And the speed becomes less. So why there is a maximum refraction here? Because again, mantle to core. And this is the medium jahan pe the P waves are experiencing least speed. This is the medium where the P waves are experiencing least speed. Can someone tell me why speed is less in this medium? Because it is liquid in nature. This proves outer core is liquid in nature. So similarly, we have P waves. We have the P waves which are recorded here. Now, can you see, this is the region jahan pe if the P wave comes inside this circle, it will suddenly bend. It will again bend and it will bend here. Or I will show you here. A P wave is going outside the circle, it is touching the circle, koi farak nahi pad raha. But once it is coming in this circle, what is happening is refraction. What is happening is refraction. So what happens at certain regions from this earth, no P wave is recorded. There will be entirely this region will be having P wave. There is no P wave recorded because of bending, and this region is known as the shadow zone of the P wave. I'll explain you for GS separately with the help of a diagram. But हमारे अभी आंसर के लिए काम का नहीं है. Now consider S wave with red color. S wave starts. उसका speed decreases, it behaves with similar to the P wave. यहाँ पे record हो गई, it has been recorded here, it has been recorded here, it has been recorded here, similarly it has been recorded here, it has been recorded even here, or it has been recorded even here, but from 105 degrees from the focus to 105 degrees from the focus, no S wave is recorded. Can someone tell me why? Because, see, S wave cannot pass or cannot go inside this. Why? Because the property of the S wave is it can pass only through solids and the outer core is liquid in nature. So how do we know the interior of the earth? सबसे पहले by direction. Write properly in the points. Don't write all these things which are present in book. अगर ये लिखा कि इसका speed ये है, उसका ऐसा change, you will not get marks. Question will come, how does it help in understanding the interior of the earth? Little bit their properties you should introduce, but then direction. Because of change in the direction, refraction, we can understand that earth is made up of different densities. Second, velocity. Both the waves experience very high velocity when the density is high. So the lowest velocity is found in crust and very highest velocity is found in the inner core. Thus we can conclude that crust is lightest and the core is densest. उसी पॉइंट में also the velocity decreases suddenly once it crosses after the depth of 2900 kilometers. This shows that outer core is liquid in nature. Then shadow zones. Define shadow zones. There are some points on the earth's surface where the wave is not recorded. That is known as the shadow zone of the particular wave. The S wave's property is that S wave cannot pass through liquid. Since the outer core is liquid in nature, no S wave is recorded between this and this, and draw a diagram. This also proves the fact that outer core is liquid in nature. Conclusion, thus, the interior of the earth, we have a complete understanding regarding the interior of the earth by the behavior of seismic waves, and the interior of the earth is as shown in the diagram below. Getting it? This is how the answer should be. On other hand, अगर ये लिखते बैठे कि उसका vibration ऐसा है, उसका vibration ये है, it is coming, that is not asked at all. That is to be studied for GS, not for optional. Getting it? Fine? Understanding? Always stick. ये तो नहीं पूछेंगे geography में explain the properties of P waves and S waves. वो physics में पूछेंगे. They will ask P waves and S waves with relation to earth. Fine? Any doubts here? Everyone? Clear? Give me a minute. You can take the introduction. Seismology. Seismology is a branch of science which studies various aspects of seismic waves. Which studies various aspects of seismic waves. That is the waves that are generated during the earthquake. Waves that are generated during the earthquake. Waves that are generated during the earthquakes. By studying the body waves, we can have a complete understanding of the interior of the earth. By studying the body waves, we can have a complete understanding of the interior of the earth. See here, P wave. What is happening in the P wave? Compression, expansion, compression, expansion. That is the compression and rarefaction. What is happening in the surface wave? S wave, up, down. फिर P wave and S wave when they will collide with the rocks के अंदर P waves and X waves both will mix with the surface rocks, and surface rocks से another waves will come out, that is known as the surface waves. And which is the most destructive? Surface wave. So surface wave, because it is an outcome of both P waves and S waves, दोनों हो रहा है. Compression is also happening and up and down also it is going. This is tremor, this is moderate earthquake, ये है death and cause. Surface waves. But surface waves के generation के लिए, for surface waves to be generated, both P wave and S wave should react with the surface rocks. But thankfully S waves do not always come, because अगर you are living at a point on the earth जिसके नीचे there is a liquid outer core का path, surface waves. So that's why कभी कभी हरियाणा में there is an earthquake का tremor felt and दिल्ली में कुछ नहीं होता. Why? Just luck. कि नीचे the path may have, दिल्ली वाला path may be having a liquid core, and therefore S wave आई नहीं, therefore no surface waves. Getting this? You already know this. Crust, mantle and core. If you want to look at the asthenosphere, this is what is the asthenosphere. This is what is the continental crust. This is what is the oceanic crust. This is what is mantle. This is outer core and this is inner core. This diagram is already in your NCERT. Fine? S waves is not passing, is not recorded here. Why? Because it is not passing through core. Why it does not pass through core? Because outer core is liquid in nature. Fine? That is what is known as shadow zone. And how the P wave is getting? It is coming here, then it is coming. So maximum refraction, deflection. You see this even in your daily life. पानी आता है. If there is a swimming pool ऐसा लगता है it is not that deep. कितना shallow है. जब jump करते हो तो पता चलता है it is so deep. Why? Because light waves bend. Is it passing from air, different density, to water, different density. So this is what is the shadow zone. Getting it? So shadow zone of P waves, shadow zone of S waves, and you have this diagrams. These diagrams are good, but हमारे काम का नहीं है, because हमारे काम का वही diagram है which you can make in the examination. You should make this diagram in the examination. Obviously, you cannot make this diagram in the examination. Fine? So you can take down. During an earthquake, there are two kinds of waves generated. There are two kinds of waves generated. That is the body waves and the surface waves. It is the body wave and the surface waves. The body waves are further divided into P waves and S waves. Are further divided into P waves and S waves. Primary wave or P wave. The first wave to be generated during an earthquake. Second point, can travel through solid, liquid and gaseous. Second point, that is, can travel through solid, liquid and the gaseous medium. Third point, travels with more speed if the density is great. Next point, great or more. Next point are longitudinal waves. That is vibrate parallel. That is, the materials vibrate parallel to the wave propagation. Fine. See, again I am saying ये सब नहीं लिखना. I am just giving it in the notes. You have to take the information as per the demand of the question. ऐसा नहीं जरूरी कि question will be only. They can ask you maybe on the seismic waves also. That is why I am giving you. But the demand of the question. Next, S waves. Or secondary waves. They are similar to light waves. क्यों हम कहते हैं similar to light waves? Because light waves जैसा it goes up and down. They are similar to light waves in which particles vibrate perpendicular to the wave direction. Travel with half the speed of P waves, half the speed of P waves, and are more destructive. I guess we have written they can pass only through solids. Have we written that? And are more destructive. And third, can pass only through solids. And last, surface waves. surface waves, these are the most destructive and are the slowest of all waves, are the slowest of all the waves. As they can pass only up to smaller depth. हम ये क्यों लिख रहे हैं surface waves even in the interior of the earth, as they can pass only up to a smaller depth, they can give idea only about earth's what? Crust. Study of these waves helps us in distinguishing between continental and oceanic crust, because most of the earthquakes originate in mantle. बहुत कम earthquakes crust में originate होते हैं. Right. So, before, which is liquid in nature? The core. So before we do write the answer, just look at a very small video. Sound is not needed. So it is trying to tell what is the importance of magnetism, plate tectonics. Inside asthenosphere, it is very, very hot. It is telling magnetism plays an important role even in the atmosphere. Not needed. Magnetism plays an important role in satellite communication, GPS tracking, and for the life on the earth. And from here our video will start. What is this? Sun. Sun के अंदर there are volcanic eruptions or there are high eruptions which are known as sunspots. Sun is a nuclear bomb which is undergoing fusion. So sometimes such winds come. Very high electromagnetically charged particles will be thrown in the atmosphere. These are known as solar winds. They are dangerous. Now when they come to the earth, you have to understand this is our magnetic field. This is all satellite image. ऐसा ही होता है in real life also. So when, see, can you see orange color? What is this doing? It is protecting the earth from the solar winds. And because solar winds are coming and pushing the earth's magnetic field, you can see magnetic field is getting extended in this direction. So every planet has such magnetic field. But earth is very strong and therefore life is possible on the earth. See, See all the charged particles फिर कहाँ पे आए? At the poles, and therefore we have aurora borealis and aurora australis. And this is what is the aurora phenomena, aurora borealis and aurora australis. Whenever you are going to see the videos, always look at who is showing you the video. It has to be either NASA or it has to be either. And this is our next question. What do you understand by the Earth's magnetosphere? Had magnetosphere not been there, they have shown you what the Earth would have been. साउंड की वैसे भी ज़रूरत नहीं है. What is this? Interaction between the solar wind and the Earth's magnetosphere. Now, why we are all doing this? Why we are looking at the videos? We are looking at the videos because this entire magnetic field of the Earth is in the may flip in our lifetime. We don't know what it will do. कोई कहता है North Pole will suddenly become the South Pole and South Pole will suddenly become the North Pole. Already the magnetic field is changing at a very, very high speed. So this entire flipping of the magnetic field. Why the magnetic field may flip? The reason for this is because, and why we cannot predict when it is going to flip. The reason for this is we have no understanding of the inner liquid. If the liquid changes uska direction, by Fleming's left hand rule, the magnetic field will change the direction. And can you see, this magnetic field is not constant. वो sun उसको compress कर सकता है, and therefore it gets compressed, and thus the sun rays can enter the interior of the earth. And imagine what will happen when it is going to flip. When it is going to flip, there बंद हो जाएगी कुछ seconds के लिए, and फिर से शुरू हो जाएगी. It will go off and it will get on. When it goes off, that few seconds are enough to destroy humanity on the earth, because then sun rays will come and hit the earth. So it will destroy all the things which depend on magnet. So what depends on magnet? Satellites, computers, electronics, watches, animals. Some of the animals have their direction. Example, birds know the direction because they can sense the magnetic field. That is why many of the birds are changing the direction and they are coming now to India. This shows the shifting of the magnetic field. And hence, you will study in environment ecology in GS, not in optional. Government of India has launched migratory bird conservation plan because numerous migratory birds are coming to India. Getting this sense? Why all this? Outer core is liquid in nature. So, how the seismic waves are important. So point number 1, I am giving you the answer. That is the relevance of seismic waves in studying the interior of the earth. So point number 1 is The other natural or artificial methods, have limitations that they do not give a complete understanding of the Earth's interior. They do not give a complete understanding of the Earth's interior. You can write any example you want. Example, complete understanding of the Earth's interior. कोई भी एग्जाम्पल लिखो जो तुम्हें पसंद आता है. एग्जाम्पल वॉल्केनो ओनली अप टू 200 kilometers. Point number 2. The seismic waves which pass through the interior of the Earth, the seismic waves which pass through the interior of the Earth through their change in velocity, comma, direction and shadow zones, direction and shadow zones have contributed in understanding the Earth. Point number 3, velocity. तीन ही पॉइंट ऊपर के एक्सप्लेन करने हैं आपको. Velocity. What you will write in velocity? Maximum velocity कहाँ पे? Core. What can we conclude by that? That it is denser. Minimum velocity, which crust? Continental या oceanic crust? Continental crust. That means, can I say the velocity of the waves goes on increasing as it is going from crust to the core, but between 30 to 200 kilometers the velocity decreases, which shows that this is the zone of weak rocks, that is the asthenosphere. And then again the velocity decreases between 2900 to 5100 kilometers. That shows that the liquid outer core is liquid. Getting it? So, velocity. The velocity of P waves and S waves. The velocity of P waves and S waves goes on increasing as it goes in the interior, full stop. The sudden change in the velocity is experienced at 30 kilometers. कहाँ पे? Below. At 30 kilometers which is known as Moho discontinuity, और simple words में crust mantle boundary. Crust mantle boundary. See, धीरे धीरे the velocity is going. 5 kilometers to it becomes 8 kilometers, and suddenly after 30 kilometers the velocity changes. So there was a person, Russian scientist known as Moho Vorikik, who studied why this change in the velocity is there, and he then discovered that at 30 kilometers is the boundary between crust and the mantle. To honor him, we call this as Moho discontinuity or crust mantle boundary. Fine. Getting it? Those whose GS has not yet been done, remember, Moho discontinuity means crust mantle boundary, nothing else. The same point. Though the velocity is greater in the mantle, but the upper 200 kilometers experience low velocity, as it is the zone of what? Magma or weak rocks. Below is a explains that it is a zone of low velocity, explains that it is the zone of, so the velocity is greater in the mantle, but the upper 200 kilometers experiences low velocity, which explains that it is the zone of weak rocks. That it is the zone of weak rocks. और what? Asthenosphere. अब क्या बचा है लिखने में? Velocity further decreases in outer core. The velocity further decreases in the outer core, as well as S waves do not pass through the outer core. And therefore, we can conclude that outer core is liquid in nature. Outer core. And therefore, we can conclude that outer core is liquid in nature. Outer core is liquid in nature. Getting the points? Direction. Next point is direction. As the waves follow a curved path, or as the waves are refracted, as the waves are refracted, we can conclude that Earth is made up of materials of different densities. We can conclude that the Earth is made up of materials of different densities. अब क्या बचा है बताना? Shadow zones. So what do you understand by shadow zone? The point where the earthquake wave is not recorded. Fine. फिर खुद को पूछो कोई स्कोप है डायग्राम बनाने का? है. First make the diagram, then always make the diagram in the exam. जहां जहां आपको स्कोप मिला. How to make a diagram? Can you carry a stencil? Yes, you can carry a rounded stencil. जिसके ऊपर triangles है. The only stencil you cannot carry is the map. India map or world map. बाकी normal stencils you can carry a circle वाला stencil. Fine. So shadow zones. First the definition. These are the zones where the seismic waves are not recorded. Leave some space for a diagram. I will dictate till the point. As the S wave is not recorded beyond 105 degrees from the focus. Is not recorded beyond 105 degrees from the focus. It proves that S waves cannot pass through outer core. S waves cannot pass through outer core due to its liquid nature. Due to its liquid nature. Similarly, the P waves also experience a smaller shadow zone. P waves also experience a smaller shadow zone due to refraction in the outer core. Examiner समझ जाएगा क्यों refraction है? Because there is sudden change in the density as it is solid to liquid in the outer core due to refraction in the outer core. Or you can draw these two diagrams. See, solid से it is coming into liquid, liquid से again it is going into solid, इसलिए बहुत ज़्यादा it is bending. इतना ज़्यादा bend हो रहा है कि certain parts में P wave नहीं है. Getting it? And यहाँ पे it is not getting recorded because it is not even passing through outer core. Don't use bangle or kada in the exam if you are not having protractor. ऐसे नॉर्मल डायग्राम बना दो, थोड़ा सर्कल हिलेगा तो चलेगा, बिकॉज कड़ा अगर यूज करोगे या बैंगल यूज करोगे तो स्पेस कम पड़ेगी. फाइन, स्पेस इज नॉट दैट मच. Can I continue? Done? Can I rub this? Yes. Thus, the modern view of the interior of the earth, thus the modern view of the interior of the earth, modern view of the interior of the earth is an outcome of complete understanding provided by the seismic waves. Complete understanding provided by the seismic waves, as shown in the diagram below. Because this is an ideal answer, इसमें से कुछ कम ज़्यादा, it's fine. You are ending also with the diagram. Can you tell me why I have written this? Because if you write upper mantle only here, that means this part is the upper mantle. Asthenosphere is also a part of upper mantle. So thoda upar जाने दो in the diagram. So if this is Moho discontinuity, crust mantle boundary, then what is the mantle core boundary? Gutenberg discontinuity. That is continental crust and oceanic crust. It is also known as Moho-Voricic या Moho, एक ही बात है. It is Gutenberg discontinuity. What is this? Mantle. ये सब इतना डिटेल में बनाना डायग्राम में. Just write the name of discontinuities. I am giving you so that you should know this. Mantle core boundary. सेमी सॉलिड. अगर लिक्विड होता तो एस फेज क्रॉस नहीं करता, बिकॉज इट इज मोल्टन सेमी सॉलिड जेली, इसलिए एस वेव क्रॉस कर पा रहा है. इसी से हमें पता लगता है कि एस्थेनोस्फीयर लिक्विड नहीं है. फाइन. हिम्मत है थोड़ी, और शुड वी स्टॉप? You have a class? I'll give you a very brief idea regarding. So can I rub this part? Continental drift theory. किसने दी थी? Wegener. But was the Wegener the first person to give this concept? No. It was given by Snyder. Now, what did the Wegener say? इससे पहले in your book there is a tetrahedral hypothesis. It is not required in our syllabus, but continental drift theory is there. So see the distribution of the continents. Why there are continents somewhere? Why there are no continents somewhere? Why there is an oceanic body? Why there are evidences of glaciation in the India, Brazil, Africa, जहाँ पे glaciers नहीं है today, और why there is coal in England, Germany, Sweden. This baffled or puzzled the scientists. Abhi you will ask me why coal? Because coal is formed only if tropical vegetation goes below fresh water. समझे? Only जो vegetation जो हमारे यहाँ है in the tropics, if it goes below the fresh water, then only the coal will be formed. So where we find coal? In the polar regions. Antarctica में why India is so much interested? Why Australia is interested? Because it is said that Antarctica is one of the largest coal reserves in the world. So in the polar regions में is there tropical मतलब गर्मी वाला vegetation? No. Tropical vegetation, the vegetation that goes in the tropics, between Tropic of Cancer and Tropic of Capricorn. So, but pole तो यहाँ मिलता है, and where we found the evidence of glaciation? In this part. That means, does it mean, if this is the equator and if this is the north and south pole, does it mean that once upon a time this was north and south pole and this was the equator? If this was the equator, then also it is not possible कि suddenly earth किसी ने ऐसे टेढ़ा कर दिया and ये बन गया north and south pole. No. It means two things. कि either the climates have changed, but for the climates to change, someone has to tilt the earth, or either the continents have changed their position. So the second thought, that continents have changed their position, that is, they may have been present at some other position and they have gone to some other position, and due to this continents have experienced climatic change, became accepted. And hence the Snyder ki idea was made into theory by Professor Alfred Wegener. Why Professor Alfred Wegener? Because he was surprised to find the deposits of coal in Sweden and England. Why वो coal क्यों ढूंढ रहा था? He was not finding the coal. He was basically a person who was a botanist who wanted to make an atlas of all the trees in the world. पर उसने देखा कि fossils of the tropical trees are found in the temperate regions. So what he says once upon a time there was one supercontinent. I will draw this as one. Once upon a time, some years ago, there was one supercontinent which is known as Pangaea. And this supercontinent was surrounded by super ocean which is known as Panthalassa. This is what he said. Then Wagner said, during a period which is known as Carboniferous period. During a period known as Carboniferous period. Carboniferous period was some between वाला period in the geological history of the earth. Precambrian से अभी तक के बीच में there was a period which is known as Carboniferous period. During the Carboniferous period, the world broke into two parts. That is, the Pangaea broke into two parts. The upper part was known as Laurasia, and the lower part was known as Gondwana land. Why Gondwana land? Because he came to India, studied the coal fields, and he found there the tribes which are living are Gonds, and he gave the entire land, just say India related as a Gondwana land. And as a result of, he said, this resulted into water which was of the Panthalassa, which came in between the Gondwana land and the Laurasia land, and this phase is known as the phase of opening up of the Tethys Sea. कौन से period में? Carboniferous period. Then he said, after the Carboniferous period, there was further drifting of the continents. Continents फिर से टूट गए, and they started moving into two different directions. Some of the continents started moving northwards, and some of the continents started moving westwards. Getting it? कुछ northwards, कुछ westwards. And as a result of this, the Laurasia broke into two parts. One part became North America and the other part became Asia or Eurasia. Fine? The Gondwana broke into many parts. One part became South America, one part became Africa, one part became Madagascar, one part became India, one part became Australia, and the other part became Antarctica. And this continent started moving in two different directions. He said North and South America moved in the westward directions, and as a result of this, फिर से water came in between, and this became the Atlantic Ocean. Fine? Panthalassa ka water was already there. This became an Atlantic Ocean. And then he said that Africa and India started moving northwards. As India started moving northwards over the period of time, America, Atlantic Ocean, Asia, Africa started moving northwards, that is, and India started moving northwards. As India started moving northwards, this ocean became an Indian Ocean. And then Australia remained here and Antarctica remained here. Over the period of time, this continued to give rise to the present day arrangement of the continents, in which we have North America and South America. We have Africa, we have peninsular India, we have Eurasia, we have the island arcs of Indonesia, and we have the Australia, New Zealand and Antarctica, to give rise to the present day arrangement of the continents. And this is what is known as an Atlantic Ocean. This is known as an Indian Ocean. Atlantic Ocean due to westward, Indian Ocean due to the northward. And what happened to the Panthalassa? The Panthalassa was reduced in size and it became the present day Pacific Ocean. What happened to the Tethys Sea? The Tethys Sea was destroyed in the part where India was there, but it is still present in the region jahan pe Africa is there, and this is what it is known as an Mediterranean Sea. And he said this is how the present day arrangement of the continents was. Fine? यहाँ तक ठीक है. फिर this theory got worldwide acceptance in 1912. Wagner जो geographer नहीं था, he thought चलो उसने he has given a theory of geography, I will expand it more. Then he did a mistake. What mistake he did? He said, he thought he can also explain the presence of mountains. He said the mountains of Andes, Rockies and Andes, Atlas, Alps are formed because as the continents were moving, उनका edge जो था, friction के कारण the edges got bent, and this bent resulted into the formation of the continents. Because Sial is floating on the seema, there was a friction. Friction कहाँ पे? Only on the edges, and because of the edges got bent, and this gave rise to mountains. Andes, Rockies, Atlas. उसको पूछा फिर, what about Himalayas? No answer. Fine? He was asked, what about Himalayas? No answer. And he forgot that his first assumption of his theory was Sial is floating on seema without resistance. And then he says that the mountains are formed due to resistance. Fine? And his second biggest mistake was he thought he will explain the formation of such islands, island arcs, Indonesia, Japan, Greenland, Sri Lanka, etc. So he said, or this is what is known as the Caribbean islands. He said, as the plates were moving with great speed, some of the parts could not keep pace, टूट गए, पीछे रह गए, and बन गए island arcs. Fine? This was Wegener's theory. No doubt, the Wegener's theory was full of errors. ये तो errors जो मैंने बताया about mountains and islands, they are very small errors. The first error is, Wegener was asked, what was the mechanism कि Earth was stable for 600-700 million years and only in the Carboniferous period वो टूट गया. What happened? Why Pangea broke only in the Carboniferous period? Wegener has no answer. Why Wegener chose Carboniferous period? Because he was interested in coal deposits and coals were formed in the Carboniferous period. So उसने theory शुरू की from the Carboniferous period. Had he been any other person, his theory would have started in some other period. He was a botanist who was interested in coal deposits. When did coal form in the world? Carboniferous. His theory starts in the Carboniferous period. Second, he was asked, what is the force that is responsible for the drift? He said there are two forces. One force is gravitational force of sun and the moon, the same force that causes high tides and low tides. Imagine Wegener saying tidal force is responsible for the movement of the continents. Is it so full of error? जो पानी को 1 मीटर ऊपर करता है और नीचे फेंकता है, that is during high tides and low tides, such a weak force, can it move the continents? When is the high tide and low tide strongest? When is the high tide and the low tide? That is, highest high tide is experienced during which day? During the day of Amavasya and Purnima. Why? For the simple fact that sun, moon and the earth are in the same line. So this is the day of Amavasya because we cannot see the moon. And this is the day of Purnima because we can see the bright side of the moon. So during this day, do you experience nowadays that you are being pulled towards the west side? No. So he's saying when the itna weak force, he's saying continents were pulled. And second, he said, second thing is the gravitational pull at the equator. If the gravitational pull was maximum at the equator, which is obviously as per the Wegener, and therefore all the continents were pulled to the north, तो फिर सबसे ज़्यादा continent should be at the equator. I am drawing the equator. This line is known as equator, and you can see equator region जहाँ पे सबसे कम continents हैं. That means his theory was wrong in the terms of force. His theory was wrong in the terms of what was the mechanism. His theory was wrong in the terms of many things. And lastly, one of his biggest mistake was, okay, he said, chalo, you don't understand force, everything is fine. Tell us how exactly the sequence was. Pehle North America tuta, pehle South America, pehle India, what was the sequence? He had no answer for this. And hence, his theory was rejected. It was rejected by the scientist. Then again वो problem आया, क्या हो रहा है क्या नहीं, nobody knew. There was one geologist जिसका बेटा उसको तंग कर रहा था. I am telling you exactly how it has happened in the world. उसका 4 year का बेटा was was asking him to play with him. अब उसने सोचा जियोलॉजिस्ट ने मुझे तंग कर रहा है, उसने एक सबसे डिफिकल्ट पजल, he gave that to that 4-year-old child, a puzzle, and said solve it and don't disturb me. The child came within 15 minutes solving the puzzle, and the geologist could not understand how he could do. He asked the child, how could you do it? He said it's very simple, there is a map behind, टर्न मैप, वो टर्न मैप पे पजल है, मैंने सिर्फ मैप्स को इकट्ठा कर दिया. उस बच्चे ने what he had done, the child had solved the puzzle by joining Africa and South America. And this was the person who thought, maybe, yes, and he again reinvented the Wegener, and he gave the evidences for the Wegener's theory. And this is how we got interested again in the Wegener. So what are the evidences? Though he was wrong, what are the first evidences? The first evidences connect all this like a child. That the entire continents fit exactly into each other. Africa fits exactly into South America. Madagascar, India, Australia, they all exactly fit into each other. This is what is not just take this Europe, put it here. This exactly fits into each other. This is what is the first evidence, that is the jigsaw fit of the continents. Second evidence is rocks which are here and the rocks which are here, they are same. Why? Because once upon a time they were joined. Same rocks hai. Third biggest evidence is this part of the world is extremely rich in gold deposits, Africa. But किसने ला के रखे gold deposits? Now you should know how the gold deposits are found. Gold deposits are found as a placer deposits. What do you mean by placer deposits? जब river is flowing, river will carve out the stone, gold from the stone, it will flow, and जब उसका speed is decreases, it will deposit the gold at some other place. Fine? But यहाँ पे पीछे तो there is no gold bearing rock. Then the scientists studied all the gold bearing rocks are here and the placer deposits are found in this region. Fine? Then fossils. सर यहाँ पे, पूंछ यहाँ पे, tail. Half of the body here, half of the body there. Today it is separated by Atlantic. But once, then how it can be? इतना बड़ा dinosaurs? No. It all shows that these continents were together. And the biggest evidence is all these areas are having glaciation ka evidence. Why? Because they were all the part of Gondwana, which was nearer to the poles. All these regions are having coal because they are part of the Eurasia, which are located here. And thus we have a plate tectonic theory in our syllabus. Then scientists started studying the plate tectonic theory, the continental drift theory, and the improved version of the continental drift theory is nothing but plate tectonic theory. Getting it? Fine? Understood everything? Theory is extremely easy. Iske baad ab syllabus is very easy. Interior of the earth, it has no linkages. Plate tectonic, fine? Getting everyone? So I'll stop here now.